Right. So, yeah, Shushmita. So good evening, everyone. Let us start the session. So today, let us discuss some of the interview questions till what we have covered. Okay. First, we'll do that. We'll give some priority to the interview questions as well because it is part of our course, 30-hour course, what we are actually trying to learn here. So let us do the interview questions. Let us discuss some of the things. Okay. So if you want to ask something or you want to, what happens is I'll share the questions and I'll start discussing on that. So anything you have or you want to say, you can put it in the chat so that we can, I can start answering your to your question. Okay, so it doesn't matter anyway because we are discussing interview questions. You can just reply. Sorry, you can just put that. I'll just take the questions from the chat and it'll just even though I'm explaining, I'll stop it and I'll get to your question. Okay, so that is not a problem because I'm not explaining a particular concept. So we are going with the interview questions. So let me share my screen first. So first of all, again, good evening to everyone. So that is the first thing I should tell. I should tell you guys. Okay, so let me just share my screen. Just give me a minute. So yeah, fine. Let us talk about the questions first, as I told you. Okay, okay, fine. Right. So, these are some of the very important questions which I have taken from. Okay. So I have done some research on, different interviews, what has happened on machine learning, and I have taken some very important questions. Okay. And let us start discussing. Okay. So let us first talk about the overview of the machine learning part. Okay. So, you should give a lot of importance, I feel, when it comes to basics of machine learning, right? Because at advanced level, to go to the advanced level, first of all, people expect you to know the basics well first. So they'll be expecting good amount of basic knowledge from you. So the very important thing is to understand the basics. So that is why we have dedicated a particular session, and then I have done some of the concepts also. So like that, we have taken some time and we have done some importance we have given to the particular area. So now let us see the first question. So what is machine learning and how does it differ from traditional programming? So this is a very common question, which I found, on the internet as well. When it comes to different companies, like even it is, it may be Google, Accenture, or any kind of company. It's a very basic question, and it's being asked very, frequently and very highly. So how does it differ from a traditional programming? How you justify, or how do you actually differentiate machine learning from a traditional programming? What you are actually having. So that is one thing which is being continuously spoken about, and people also keep on asking. So to answer this question, right? To answer this question, how does it differ from the regular programming languages? Is here what exactly we are doing in machine learning. So basically, machine learning, what we are trying to do is we are trying to build a model, right? So it's more compared when it comes to decision making, right? When it comes to decision making, or building a particular building a particular pattern, or building something where you can actually talk about machine learning in that perspective, right? So here we are going to build a model. From that, we are going to take a decision, right? So traditional programming follows in some explicit rules, right? So for example, like, we are giving some rules and then we are getting an output. But for machine learning, it is not like that. Machine learning, it is very important that here what we are doing is we are giving some data, right? So even many people get a doubt where, even the traditional algorithms, we give the data. No, sir. So how come machine learning, you're saying it is different in that perspective? So how it is different in that perspective is, machine learning, it's not just about, data, and uh, it's also about building some algorithms that is not existing in the traditional programming. So that is in where the algorithm part comes into the picture when it comes to the machine learning. Okay, so this is very important to answer. You have to focus more on that algorithmic basis, where on that algorithm basis where you can tell that machine learning is different, in the point of view of applying an algorithm to a data compared to a traditional programming. Right. So let us go to the next part. So explain the differences between supervised, unsupervised, and reinforcement learning. So this is a very, this is a very basic question, and you can actually answer this question. If you just even Google about it, you can answer this question. So this is not a, a very great thing, which you cannot answer, because when you learn machine learning, obviously you will learn what is the supervised, unsupervised, and reinforcement learning. So you can directly answer this question stating that, this is how an unsupervised learning looks like, and this is how a supervised, and this is what reinforcement is about. So these are the differences between, just pick some couple of points, and you can also, maybe you can, do things. Just tell a basic definition. Then maybe you can come to the goal of, you can just tell the goal, why supervised is used, one unsupervised is used, and why is reinforcement used. You can just talk about the goal of why these three are existing, first of all, when it comes to machine learning. And yeah, you can just tell the definition, you can tell the goal, and you can tell one example. You can just tell a very basic example. This is how it is used. For example, if the interviewer asks, tell me a bigger application where, how do you really apply, and he goes to that extent, then you can tell bigger examples. But just tell us very small example, uh, you know, um, for unsupervised, supervised, and reinforcement. Just tell a basic example, and just close out the thing. So just tell the definition, goal, and speak about the example in a very brief way. Okay. So next, relating to this question, I found this also very interesting, which has come up. So this is again a very basic question, and this will be actually linked to the second question. So supervised, unsupervised, and reinforcement learning, and based on this three concepts, give me some real world applications. This is one question. If together they might ask. Okay, so you can justify by telling some real world examples, and particularly I will tell you, uh, you know um, 10 examples on, particularly when it comes to finance domain. So finance domain you focus on, finance domain you tell the examples or applications, and maybe you can take healthcare domain as well, right? These are very trending, and where machine learning is basically, and you can say very highly used. Even inventory you can touch, supply chain logistics. So very few areas which are very highly used, and very highly used, and very well appreciated. So that kind of applications you pick. So don't pick very basic spam filtering, email filtering like this. Don't tell very vague answers. So just tell some big predictions, like drug discovery, particular disease prediction, diagnostics, like in logistics, traffic predictions, right? Then maybe fraud detections in the finance companies. Any particular example, if they ask, you can talk about any fraud detection in a particular company. So because we'll also be discussing on online fraud detection. So when we discuss decision trees and random forest, I have a data set where we use an online payment methods to, particularly UPI payments and all. Let us, how they can be flagged as a fraudulent transaction or a genuine transaction. So we try to apply that kind of. That's why I'm also focused more on finance data sets also, because it is always easy for you to tell that this kind of project I worked on, this kind of application I have actually done, and this is how it will be actually implemented in the real world, and all those things. You can come, you can also take up an example of the project what you have done. That is why we learn machine learning mostly to project, not by just going. Just understanding the concept is very important, because without a concept we cannot implement. So but through project you learn more. So you can just give a basic project understanding, and just a basic understanding, and how it can link to the real world and all. You can just give one very brief applications. But I will tell some very important, like healthcare and finance. Please touch up supply chain, like that kind of very, not very basic, um, not very basic examples. Don't tell very basic examples. So they'll feel like, oh, this fellow is not done much on machine learning and all. So that kind of that kind of atmosphere don't create. Okay. So next is, what are the main challenges in implementing machine learning models? So these are the toughest part. Why? Because actually implementing machine learning and deep learning is actually a difficult part. Why? Because data has different kinds of problems. So keeping that in mind, there are a lot of challenges. So you can actually talk about uh, the most important problem. Sorry, the most important problem when it comes to building a machine learning model. The most important problem is the quality of data. This is the biggest challenge, right? So this is the biggest challenge people face, right? So coming, to understand, what exactly, you know the problems, or in practical problems where we just take a small project, build a model and all. So that is not exactly what we do in a higher note. So there are some issues, right? For example, like data quality, as I told you. And one more biggest problem with even with database, what I feel is the imbalance in the data. That is a very huge problem actually, because when you have to train, what happens is, if you have an imbalance. For example, this online transaction fraud and non-fraud cases, let us take. So difficulty part is, when you take a data set, a finance data set, which is with fraud and non-fraud and transactions, obviously you will have non-fraud transactions more in the data set, because you cannot identify fraud transactions more. Very less it's going to be. So obviously what happens is, for example, when you take a data set, maybe 90% will be your non-fraudulent transactions, and 10% will be your fraudulent transaction. So now, sir, then what is the difficulty in this? The difficulty in this is, when you are training the algorithm, the algorithm shows biasness. So it shows the biasness towards the non-fraudulent transactions, which is not good for the model. Here, the bias, that is why bias and variance trade-off is here such a hell of a problem when it comes to building a machine learning model. Why? Because this is what, because one of the examples is this imbalance in the data set. So 90%, that means the model, it obviously shows some bias, right? It obviously shows some bias when it comes to the model building, right? And the toughest part is when it shows some bias in model building. Obviously the outcomes, the accuracy, the outcomes, the predictions, uh, obviously will go haywire. So that is, we have to keep in mind. That is why I told, dealing with the quality of the data, and this imbalance in the data set is a huge problem. So talk about the problems which are, like, some problems which are very, very difficult. So speak about those problems which are extremely difficult. Okay, just give me a minute. So talk about the challenges and problems which are extremely uh, you know uh, toughest part, and how these are going to affect when you are building a model, and how these are actually giving you actually as a challenge. So really, the challenge word has to be justified. So in that case, talk about those kind of applications which are actually uh, you know telling you about. So next, basically, is how do you choose between a rule-based system and a machine learning model for a given problem? So this is very similar to that of the first question. Actually, I would say first question and fifth question are very similar. The framing of even though I felt they are very similar, I just took it because I just wanted to show you as well that a question can be asked like this also. So when I saw this question, I felt this is exactly same, like how it is different from the traditional programming, very similar. This is because we are talking about the rule based with some logics, and here we are talking about the uh, 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 the algorithmic approach, right? So that is almost same, but the framing of the question is different. Okay, so let us go to the next part, which is the some of the key concepts. So these are five important questions. What I felt, I found many actually coming. Talking about when I done my research on different questions from different companies. I come up with these five questions, which from the key basics, or you can say key concepts. So one of the important question I found was this bias variance trade-off, which is a very common question. When we are conducting interviews, also we ask the people. So this is a very, very common question. What is underfitting, overfitting? What is the difference between a classification and a regression model, or a classification and a regression problem, right? And what is this bias and variance trade-off? Your very common questions, very, very common questions. So this you have to be ready. So if the interview doesn't ask this, you can feel disappointed. So that that amount of important or importance you can give for bias and variance trade-off. So in a very, very simple language, if you ask me how to answer what is variance and bias trade-off. So very simple answer is basically bias is uh, creating very simplistic assumptions. Okay, so in a very simple word, I can say this is basically an error. See, obviously both are errors, first of all. So that you should both are both are errors. So many people feel variance is only error, bias is not an error. No, absolutely not. Both are errors. Okay, first of all, get that straight. Both are basically errors. Okay. So then, what is the difference between these two errors? How we, if somebody asks us, how we tell it, right? So basically, bias is something where we, it's a kind of error where we are usually, giving some simplistic assumptions. Okay. So basically, what happens is if you are having high bias, okay, so high bias basically leads to underfitting. Okay, and because why high bias leads to underfitting is the data faces difficulty. Basically, the data faces difficulty to capture the underlying facts. Okay, so since the data is facing difficulty to capture the underlying facts, what happens is it tries to go for underfitting. Okay, so this is the biggest problem which comes in bias. Now, coming to the variance part. So variance is, basically I can say variance is very sensitive to fluctuations in the data. So, high amount of observations come in, or very low amount of observations come in. What happens to the data is there will be a lot of fluctuations in the data set. So this actually leads to overfitting problem. So you can remember like this, that high bias leads to underfitting, and high variance leads to overfitting. Okay. Yeah, high variance leads to overfitting, and high bias leads to underfitting. So this, like this, you can remember. And what is the trade-off here is it is very important to reduce the bias and increase the variance. It is better that the model overfits, you can adjust than underfitting. Let me tell you one thing. Let me tell you one thing. Always remember, overfitting is much better than underfitting. In my experience, also I've encountered that. Because underfitting is, it's not even capturing anything, any underlying patterns. Ayo, that is ridiculous. Because we are not able to, our model is not able to capture anything. So apart from that, instead, if at least it captures the noise, it is capturing something. So that is why I'm telling the trade-off is basically what is, we are trading off the high bias part. Why? Because high bias is leading to underfitting. So underfitting, we don't want. Absolutely, I don't want underfitting. So even I'm fine with overfitting. So high bias I don't want. That means that definitely I don't want my underfitting. So now what should I do? I cannot control both. So high bias I will accept, sorry, high bias I will remove. That means I'm accepting low bias. So if I'm accepting low bias, that means I should accept high variance. Okay, fine. Now all this is good, but sir, we know that, overfitting and underfitting both are problems, but you're saying underfitting is fine for the time being. Yes, it's fine because because we can address the problem of overfitting by using regularization, right? So at least we can do something with the overfitting because the problem gets rectified. So somewhere down the line, you can feel that overfitting is somewhat better, right? So then from there you can take it up, where you can slowly try to apply the regularization part, and then you can reduce the overfitting and you can make sure that the model performs well. So this is how you should answer the question for bias variance trade-off, because this is a very tricky question, and the person will be because if you're able to answer this question correctly, it obviously will cover the concept of overfitting and underfitting also. So what happens is the person who is interviewing you, he will understand that, okay, fine. Okay, this fellow knows how he wants his model, first of all. That means he knows how to build a model. Okay. So that means he knows how to deal with the data. So, that kind of, these two questions create a lot of impression on you, because I'm telling, variance bias trade-off and overfitting and underfitting questions will be 100% will be asked in the interview. Just write it down, mark my words. It's such an important question, and you should be answering it very, very very, very nice way, right? So that okay, oh wow, this fellow, yes, he knows how to build a model. This fellow knows how to understand the data. So such a thing you have to create. Okay, so that is what these two are more about. So coming to the parametric and non-parametric model. So what is this parametric and non-parametric models is? So basically, parameters are nothing but is a particular value, right? Like a constant. But constant is somewhere where it is same throughout a particular problem. But parameters are somewhere where it takes different values. For example, when you have seen the linear regression model, you have seen the function y is equal to beta naught plus beta 1x, right? So those are called as the parameters. Okay, parameters and constants. So example, what is the difference, right? We have a certain values need to be predicted. For example, a very easiest way you can tell linear regression, logistic regression, because all these have a certain formulas where you are assuming a parameter, right? A particular parameter. But models like the k nearest neighbor or decision trees, right? So these are some of the models which you are not predicting any value, right? You are not predicting any values. So since you're not assuming any values, definitely you're not predicting any particular variable or value. Definitely, you can say there is no parameter involved, right? There are some formulas when it comes to decision tree, k-nearest neighbor, but you're not really predicting any parameter. So you can safely say, like, there are models such as k-nearest neighbor and decision trees. We do not have parameters. Okay. So next, one more common question is, classification and regression problem. So I think you have already understood what's the classification. Yeah. So, classification is something where you are predicting a categorical variable, which is not a numerical variable. So regression problem is somewhere where you are predicting a numerical variable. So you can just tell that in a very simple way. So if the person asks to, elaborate some more examples and all, you can just tell one or two examples, and you can also tell about the metrics. Yeah, if he asks, okay. So don't tell, just tell that, classification is used for categorical and regression is used for numerical. This is the main difference. These are two comes under supervised learning. This should be fine. Okay. If he asks, what are the metrics? Is that the same metrics what you use? How do you evaluate them? What are the metrics which will be used for classification and regression problem? Are they same? If this question comes, then you can tell that, no. For regression, we use the mean square error, root mean square error, right? R square. And then for classification, we use the metrics like AUC, ROC curve, F1 score, right? Precision, recall, accuracy, all these things will be used. So because the outcome variable is different for both classification and regression, we cannot use the same metrics to evaluate the type of problem. So definitely we have different metrics also. So you can justify your answer like that. Okay. So next is what are hyperparameters and why are they important in machine learning models? So coming about the hyperparameters or the hyperparameters, which this is also not a very regular question, but they ask about hyperparametric tuning. How do you do that? But basically, when you talk about the hyperparameters are nothing but which is based upon parameters. First of all, okay, it's a two word. Okay, so first of all, you should know what are parameters. So anyway, you have already understood what is a parameter, right? Something we are actually going to predict. Now, when it comes to building a model, right? So hyperparameters, what happens is they are not directly learned but are tuned manually. That is why we are actually calling it as hyperparametric. For example, like a learning rate. Okay. So when it comes to deep learning part, we call learning rate, activation functions, right? We use the ridge regression, lasso regression, which are the regularization concepts. Okay. So what happens with hyperparametric tuning is basically it builds, or I can say it helps in model performance. It helps in model performance, and it also helps in the generalization, right? That means the evaluation part, right? So it properly tunes the data. Okay. So in that way, hyperparametric tuning is actually helpful. Right. So let us go to the next question, which is the data pre-processing. But before that, let me take some questions if you have. Let me check the chat. Um, just give me a minute. So any questions you can ask on the concepts what we have discussed? All good. We can move forward. Okay. Yeah, I'll just tell you. Just give me a minute. I'm just checking the other questions also. Okay. So just give me a minute. Questions. Just a minute. Yeah, I'll just tell you. I'm just checking the other questions also. Just give me a minute. Not much, I guess. Fine. Okay, great. Um, I don't think anything is there. Okay, fine. All right. So I think a couple of people asked me. Anyway, I've discussed what is hyperparametric tuning, but I'll just come back. No problem. Let me just go back to the question. I don't think. Okay, fine. No problem. So see, how to make you to understand hyperparametric tuning is particularly see. Think like this, where first of all, let me go back to the part of parameter. Okay. So I was telling that a parameter is something where it's a value which will be actually predicted or analyzed. Particularly, for example, like I can say, I already gave you the example of linear regression and logistic regression. So there we are particularly predicting a particular value. So that is what a parameter is basically is. Now the problem comes is why we are calling or why we are first of all addressing the concept of hyperparametric. Just a minute. It is like a parameter used in the algorithms, but there is a little tricky part when it comes to hyperparameter that I'm just thinking in my head to simplify as much as possible to make you to understand. So I can say basically a parameter is something where which is try to predict. Yeah, I think this is fine for you, right? Now, what exactly happens, for example, when it comes to a data set? Okay, so yeah, I think this example should be fine. So for example, we have a data set. Okay, so there are some 10 variables in a data set. Okay, fine. Now you're building, let me say you're building a particular model. Okay, now what happens is in that 10, let us say some 9 are independent variables. Yeah, obviously. 10th one is a dependent variable, or you can say target variable, or variable which is or a outcome variable. Okay, fine. Now, what is very important is we should identify whether it might be any model, right? Right from linear regression, logistic regression, decision tree, random forest, SPM, any kind of model. When we talk about a particular model, the most important thing when it comes to features, right, columns, is we should be able to identify which column is contributing more, right? So this we have understood when we are doing linear regression and logistic regression also. So which column or feature, okay, we actually industry standard, we call it as a feature. So which feature is actually contributing? Okay. So which is actually contributing to the outcome variable. For example, let us say, as I told you, nine independent variables and one dependent variable. So in that, let us say some only 3 variables are contributing. The rest 6 are not contributing very much. Okay, maybe that is why we use the dimensionality reduction technique also. I told you, right? Maybe you can remember, where you can identify which are the features which are contributing at least 95%, at least 95%, which is the industry standard. So let us say I've identified in that 9 variables some 3 variables, okay, which are contributing 96%. Just for assumption, no? Just for assumption. What is there? We can assume something, no problem. So these 3 variables are contributing at least 96% of the data. Now, what happens is which particular features are contributing that we have to identify and focus more to train the machine. That is what basically a hyperparameter. That means which are more contributing. That is what, for example. So let me take one more example also. Best example is learning rate. Okay. Uh, I think we have not covered the decision trees yet, but the number of trees in a random forest, depth in a decision tree, okay, number of hidden layers, these are actually called as hyperparameters. So something which is significantly, which is significantly contributing. Okay, so I can say which is significantly contributing. So I think this line should make your understanding of hyperparameter very easy. So, huh. So which are the key parameters which are contributing, or which are the key features which are contributing. Okay, so that is what is basically. So we tune that particular parameters which are helping us to predict the outcome variable or contribute to the outcome variable. So this is what exactly is hyperparametric tuning is. So when it comes to what happens is, we some of the common techniques, some of the common techniques what we use is something called as a Bayesian optimization is there, right? So Bayesian optimization is basically based upon I can say this is based upon the probabilistic models. Okay, because Bayes is Thomas Bayes theorem and all. Yeah. So it is focused more on the probability aspect. Okay, and yeah, even the random forest optimization, or we have one more name for random forest optimization, which is gradient boosted. Yeah, yeah, gradient boosted. Yeah, because it's an ensemble technique. Yes, gradient boosted optimization. So we give this name also for the random forest. So this is in way, see, for example, when it comes to linear regression, you can say regularization and learning rate are the hyperparameters. For example, decision tree, the depth of the tree, okay, because I just speak about that depth part and all when we go to decision trees. But in decision trees, more the unwanted branches and all, it becomes pruning, right? So unwanted branches and all. So we don't want that. So we want minimum splitting and good amount of decision making. So the number of trees what we have in random forest we call it as hyperparameter. So learning rates and all these things comes under hyperparameters. So this is the main purpose of using the hyperparameters. So it is basically used to achieve an optimal model, or I can say building of an optimal model, right? So this is where we can use the hyperparameters. Okay. Just give me a minute. Let me see any other questions. Questions. Yes. Um, I have to check this also. Okay, I don't think we have. Fine. Okay. I think it's all good. We can go forward. Great. So next is data pre-processing steps. Okay. So, to be fair, or to be frank, the most common questions I found this, but I would, if you ask, sir, what is your suggestion, which question you can expect? In the six, you can pick one, a very good question, right? Very, usually people ask, how would you handle outliers and all? So you can tell, IQR method, box plot and all. And even one hot encoding is also basically asked. Okay, so let us see in an order. Okay, so why is data processing necessary? Sorry, data pre-processing necessary in a machine learning? So first of all, why is it necessary? So we have to identify why this data pre-processing is basically required. Okay, now what do we usually tell? If somebody asked, why? Because we know that a data, is not very consistent. So every data is not very consistent, correct? No. So there are a lot of inconsistencies, irrelevant informations, maybe noise in the data. Basically what happens with these is it's going to affect on the model's performance. So even the data quality, which is a very important aspect, comes into data pre-processing. So here, what we are going to do, we are going to remove any bias in the data, right? So any missing data or incomplete data, any inconsistency, any accuracy in the data, or any you feel that the data is not validated properly. So all these things can be identified when we do the process of data pre-processing. So at that stage, we can identify many things what we can actually do. So next is what is the role of feature scaling and what techniques are commonly used. So when it comes to the feature scaling, so feature scaling is basically using the techniques of normalization and standardization. So this actually in depth only I have discussed when we have actually discussed the concepts, when we have discussed the basic concepts. So techniques like we can use the normalization and standardization. So I think the even the next question is only that. So basically you can say 2 and 3 are most commonly or mostly linked. But here what is happening in the third question is that particularly asking what is normalization and standardization. But in second question they are saying what is feature scaling, right? So little different, right? So basically, feature scaling is done for numerical data because we are applying some statistical techniques to reduce the size of the data. So, or bring down the data into a an even form. So one hot encoding is exactly the opposite because it is used for categorical data. So you can remember feature scaling and one hot encoding. I can say one hot encoding in one go because feature scaling is basically done for numerical data and one hot encoding is basically done for classified data. I can say categorical data. Okay, so that is how you can remember. So, coming to the second question, it's linked with that third question where what is normalization and what is standardization? How does it actually do? Okay. So next thing is next part. Let us go to the next question. How do you handle missing data in the missing data in a data set? So this is where you use different techniques. One of the standard techniques, what we use is the median, measures of central tendency. So ideally, we don't use mean because it is more prone to outliers, right? So mean is basically prone to outliers. So basically, we are going to use the median part uh, to I can say do the part where you can replace the values because it's a positional average. So you can use the median part and you can also use the techniques like the k nearest neighbor, right? So KNN, that also we'll see in the coming sessions. And we have regression techniques and deep learning models also, which you can use it for, uh, which you can use it for which you can use it for replacing the missing values. So like this, you can basically answer what exactly we can exactly mention that 4 5 methods which are used. again, you can exactly mention that 4 or 5 methods which are used to handle the missing data. Exactly, hit that straight point. Don't say this thing, that thing, and all. Directly tell, yes, these are the 4 or 5 methods which are actually used in any data set at any standard to basically replace this value. So imputation, we have this one also. This one, Newton's method. I'm forgetting method. So there, yeah, one method is there, Newton's method also. That is also basically used. So that is used interpolation. Yes, yeah, just remembered. So Newton's forward backward interpolation method is also used. So interpolation is also a very strong method which is used to replace the missing values. Yeah, I remember now. So interpolation, regression methods, k nearest neighbor, deep learning techniques are also used. We also use the median or mean based on the situation. Yeah, so these are some of the methods which you can use. So one hot encoding we anyway have discussed. This is basically giving numbers to the. This is basically giving categorical numbers to that of the, sorry, numerical values to the categorical variables. So this one we already know. For example, when we have like male, female, and all, so you can give numbers. Correct? No. Yeah. So something like that. Yes or a no. You can give yes 1 and no 0. So like that you can give different numbers. That's basically one hot encoding. So next is, how do you detect and handle the outliers? So this is basically the same thing as before, but here you have to just mention some statistical methods. Some statistical methods to identify the outliers. For example, the very famous method to identify the outliers is the z-score. Sorry. So it is the z-score. So basically, z-score is used to find the outliers in the data. So it's basically a statistical method. And apart from z-score, you can use the IQR also, interquartile range, which is IQR you can use, which is based upon quartiles. Okay, so quartiles are methods in measures of dispersion. Okay, so in measures of dispersion, we have the concept of quartiles. So you can use the IQR and you can find the lower bound and the upper bound, and you can remove the outliers. So this is one method. And then there's one more method. I think in clustering, we can use this DB scan. There is one name for it, just called as an, for this one, for anomalies and all, we use it much actually. It's basically isolation forest. Yes, this is that is isolation forest. Yes, so isolation forest is one actually. It's one such method which is actually used. So isolation forest is actually a method in the DB scan. So isolation forest, then you can use the IQR and the z-score to detect and handle the outliers. So box plot basically builds the 5-point summary. Yeah, it's basically a visualization of IQR, because IQR can calculate the same thing, even the box plot calculates the same thing. So I think it's fine. You can calculate the box plot and you can identify, or you can go by the physical formula of the IQR. So anything is fine, you'll get your answer. So next is introduction to the regression and classification. So this is where we go little deep now into the subject part. So what are the difference between regression and classification tasks in machine learning? So I think you know the answer for this question, because basically regression is for predicting the continuous variable and classification is used for categorical variable. So this also we know. You can give an example for predicting, like house price prediction, stock prediction, temperature, salary, all those things are regressions, and email spam detection, sentiment analysis, right? Image recognition. So yeah, so in medical you can say prediction of disease or not. Correct, no? Yeah. So all those things you can give some basic examples of what is regression and classification. What are the you can say what are the differences? You can just tell how they are applied. Okay. So next is give examples of algorithms used for regression and classification. So this one you can all, when you learn algorithms, obviously you can directly tell the answer, because this question is basically, I found one or two places they have asked this question. That's why I felt, okay, fine, let me put. But usually people don't ask, because you will be, see, if you're saying you're implemented all the machine learning algorithms, you know which one is doing classification, which one is doing regression. Okay, if you answer that also wrong, so that the interviewer will feel that you don't even know the algorithms. So that is one part which you have to be careful. It is a very easy question, and it is also a question where it might give you a wrong impression about you. So yes, be careful. I can say be careful in this question. Okay. So regression algorithms, basically you can say linear regression, right? You can say this decision trees also, because decision trees does both classification and regression. Random forest also does both. Then you have in support vector machines also SVM. You have sorry. Again, in support vector machines, we have both. One is support vector classifier and one is support vector regression. So same like decision trees, but in decision trees we call it with the name cart. Okay, classification and regression trees. Yes. So this is the name which is given for classification. Sorry, regression techniques. Cart. For random forest, we don't have a name. We usually call it as random forest regression. Same like support vector regression, right? And neural networks also we can use the for continuous. So for classification, there are many algorithms. For example, like the k nearest neighbor, uh, naive-Bayes algorithm, logistic regression, and decision trees also, which can be used for classification. So in decision trees, we have C 4.5, C 5.0, ID3. Yeah. So especially these are used for classification in uh, decision trees. And random forest classifier is basically there. So decision trees, random forest. See, decision trees, random forest, support vector, uh, and neural networks. So these are basically used for both. Apart from that, we use the particularly we can say for classification. Only classification is tell me an algorithm which only does classification. So if this is the question, okay, maybe you can tell logistic regression, naive Bayes algorithm, okay, because naive Bayes also does regression actually, to be fair, but we don't use it. It's not that accurate for predicting a continuous variable. Okay, so I had a very bad experience constructing a regression, predicting a value using naive Bayes. So it doesn't do actually, but classification naive Bayes is very good. So like that you can anyway once you learn all the algorithms, obviously you will be in a position to answer this question very easily. Okay, trust me. So how do you evaluate the performance of regression models versus classification? I think this question I need not answer. I think we already have discussed this. Okay, so I should have removed this question. Not required, but this kind of framing also has been asked. So I thought, why not? How do you evaluate versus the classification model? So you have your classification models uh, measures, and you have your regression models models to evaluate the performance. So next comes the significance of decision boundaries in the classification problem. This one you can answer by keeping in mind some of the algorithms, like best example, this SVM. So I don't know how much you guys know SVM, but we will discuss in this program. But SVM is one such model which is based upon this decision boundaries. Even this logistic regression also. But one thing, when we talk about decision boundaries, one thing comes to my mind. Logistic regression is basically a non-linear method, but the problem is when you draw a particular boundary, it is basically coming under the linear boundary. I can say linear classifier, I can say. But if I say something where this SVM, which is support vector machines, this is basically uh, a classifier completely comes under non-linear. So what about this decision boundary is something which is used to segregate two classes. So something which is used to segregate, for example, it is a yes or a no scenario or a true or a false scenario. So the boundary decision where, if it comes above that boundary, it is a yes, below that boundary, it comes as a no. So if it comes, you have a certain line which is, putting yes or no scenario or a true or a false scenario, and you're able to predict using that particular line, that becomes a decision boundary. So this decision boundary usually helps you to predict. Okay. I think yeah. So that much is enough. I feel that is more than sufficient to answer that question. So what are some common metrics used for evaluating the classification? So this is again very similar to that of the third question. So I'm skipping this. So let us go to the linear regression part. So when they start going deep, so a lot of questions comes into their mind when it comes to the linear regression part. Okay, because linear regression is one such algorithm as well. Okay, so when we talk about the linear regression part, the most important thing is we all know that linear regression is basically used for predicting a continuous variable. Correct, no? So that is what the most important line which you have to convey when they ask about linear regression. And one more important thing is how it is used and where it is used. You have to tell that this is basically a model which is giving you the relationship between an input variable and an output variable. So those are nothing but the independent variables and the dependent variables, or you can say the target and the features. So it is basically predicting a continuous variable. And some examples you can just tell. So explain the equation of a simple linear regression model. This we have covered when we have done the theoretical concept on linear regression model. So you can tell what is y is equal to beta naught plus beta 1x, and you can explain what is beta naught and beta 1. So next is what is the difference between simple and multiple linear regression? So if you are having only one independent variable, it is called as simple linear regression. If you're having more than one, let us say 2, 3, 4, 5, and so on. So that becomes a multiple linear regression. So if you want, you can just write down the equation and show and all those things. I don't think that is required. That one particular sentence actually helps you to answer the question. So no problem. What are the main assumptions of linear regression? So for linear regression, the most important assumption which you can actually tell is the independence, linearity, homoscedasticity, which you have already discussed, and then the normality part. The residues should be normally distributed. And then the homoscedasticity part where the variance is constant across all the levels. Uh, the observations, no, the variables are independent of each other. Yes, this is one thing. And always there should be a linearity or a linear relationship between independent and the dependent variable. So this is one more important thing. And not but last but not least, even the multi-collinearity part. Yes, so it's very important that the independent variables should not be highly correlated. So that is uh, yeah, that is one thing also which are coming under, or which are actually called as the assumptions of a linear regression. So next is, how do you differentiate between linear and logistic regression? So this one, I think you can tell the answer very easily because both are different. They have their own approach. One is predicting the categorical and one is predicting the linear, or you can say numerical value. So like that, you can answer the question. Okay. So next is the mathematical understanding, where what is the purpose of the cost function? So some people, why I have touched the mathematical understanding part, I'll tell you. When I faced interviews, or when I was conducting interviews, I've seen people asking the mathematical part uh, when it comes to the particular algorithm, okay, this doesn't happen very often, but there will be people who are, more from, mathematical statistical background, who are more into formulas and, stuff. They keep on asking these questions, all right? They just want to check your formula knowledge as well. So you can't rule out, right? You can fight with the interviewer. Correct, no? So you can't rule out that particular option. So what you should do is, just, on at least a briefer note, maybe you can tell, I'm not very much into formulas, but I have some idea about, this is how things work. Yeah, that should actually be sufficient to answer this question. Okay, so to answer this questions, particularly on the mathematical understanding, actually. So now let us answer these questions. Okay, how on a very brief note you can answer, I'll tell you. Okay, so what is the purpose of the cost function? So basically, cost function is nothing but a function which is trying to maximize the cost. So what happens is you have to minimize the error part. Okay, so the cost function actually they try to find the error between the predicted and the actual value. So the function, the error function basically has to be minimized. Okay, so you can just tell the formula what you know. So next is the least squares method. Explain the concept in a least squares method. So for this question, what you can actually answer is you can just again give the formula if you know, or you can just say, I'm not much into formulas, so I don't know much. But I told like it's not that simple also to just tell like that. So it is so that is also not a good way to justify. So you can just tell because it's basically a very simple formula. Maybe you can just have a glance just before an interview day, something like that. So next is the what is the role of intercept and slope. So basically, intercept is nothing but the a fixed value, right? And slope is nothing but the rate of change. Okay, so basically it's a direction and magnitude is what the so in very simple term, if you tell this, I don't know how much you are into this, but I can actually what is slope. Slope is nothing but the rate of change in the unit of y and x. Okay, but if you talk in the language of mathematics and physics, so it is basically the direction and magnitude. So it is basically a direction and magnitude which shows the effect of each feature on the target variable. This is what is slope. This is the correct definition. The direction and magnitude, the effect of direction, the magnitude and direction, which shows the effect of each independent feature on that target variable is what slope is. So this is what mathematical definition of what is slope actually is. Okay. So next, let us go to the next question, which is what is multicollinearity and what is multicollinearity and how does it affect linear regression? Okay. So so multicollinearity is basically a problem where the independent variables are not highly correlated. So we should not ideally have independent variables being correlated much. So maybe we can try to minimize the. That is why we say when we are building a linear regression model that the independent variables should not have much correlation. Okay, then the multicollinearity problem doesn't occur. Okay, so it is very important that they don't have this multicollinearity and it actually built in such a way that that doesn't affect in decision making and all those things. So that is about it. And yeah, if some people again go into the detection part, okay. So if you're good at identifying multicollinearity, if you have read some econometrics and all, you'll be able to answer. Or maybe you can remember this very important metric because definitely you will do this when you are doing the checking for multicollinearity. Measure, one such measure, what you will actually one such measure, what you will actually use is uh, the method how to detect multicollinearity. We use one method which is VIF. Yes, variance inflation factor. So yes, yeah, VIF, variance inflation factor. So this is a kind of covariance matrix, sorry, correlation matrix, which will give you the, which will help you to detect the multicollinearity. So I know some, so we can use techniques like, dimensionality reduction techniques like PCA, and all this. That is what I'm trying to tell you. It becomes a little more mathematical for some people who are very, if it is difficult for you to, talk mathematically, don't talk much. Okay, just tell that, it is ideally a measure which is, which is not good for the model building. Ideally, because we don't want correlation between the variables. So that much you can tell. If somebody asks in depth, maybe you can answer. Okay. So that is one thing I can tell you. So next is, how do you interpret the coefficients of a linear regression model? So how do you do the interpretation part? So interpretation part is, you can just tell them that how a regression line works, okay, and how the value, of how the value of one variable impacts the how the value of one variable actually impacts the whole regression line. Maybe you can talk about a regression line and you can just give some example. Okay, that should be fine. So let us go to the next question, which is model building and evaluation on linear regression. Okay. So how do you assess the goodness of fit for a linear regression model? So goodness of fit is being found by using the method called as R square. So R square, when you have built a linear regression model, I have already explained it to you. So R square is basically, I can say R square is basically how much the, the proportion of variance in the dependent variable is explained by the independent variables. So how much of, sorry, how much of change, the measure of proportion, right? The measure of proportion, uh, okay. The measure of proportion where, the measure of proportion where how much, right? These independent variables are basically explaining your dependent variable is what R square is. So there's a high chance that people might ask R square, right? Because this is more, related towards a statistical point of view. Because there is one more name for R square, R squared actually. It is called as coefficient of determination. Okay. So coefficient of determination. So how much of determination that the independent variables are having towards the outcome variable. That is why we are calling it as coefficient of determination. Then adjusted R square you can just take out of the picture. It is actually helping you to prevent the model from overfitting. Okay. If somebody asks, you can tell, or just you can just, don't answer that on R square. Okay. Sorry, adjusted R square. So next is the root mean square error and root mean square error. You can just tell. Okay. So next thing is, it's very similar, this R squared question, but the 11th question will actually cover the other things also, root mean square error and all. But 12th question only covers the R square part. And how does it differ from adjusted R square? As I already have given you one indication that, adjusted R square is more focused on the, uh, you know, um, let me tell you on a very simple note. I don't want to complicate. Very simple, I'll tell you. If somebody asks you what is the difference between R square and adjusted R square, you can just tell them that, adjusted R square decreases if the variable, you can tell like this. Yes, if the variable does not improve the model. So why we are using the adjusted R square? Okay, first of all, that maybe this question we should discuss. Okay, I just thought to leave this, but okay, fine. Let us discuss also. So basically, what does this adjusted R square does is it actually tries to predict the number of predictors. Okay, it tries to predict the number of predictors. Okay, now. what it does is it tries to penalize, okay, any additional information which is there on the variables. Okay. So this is basically, like a regularization concept. Okay. So yeah, it is like a regularization, which is penalizing the input variables. It is the same thing what the adjusted R square does. Now, this R square actually focuses on, it more focuses on, it more focuses on how much your input variables are actually explaining. So there is a small difference between this. So residuals by the total we calculate actually 1 minus, yeah, sum of squares of residuals by sum of squares, uh, yeah, residuals divided by sum of squares of total. Yeah. So we also use the degrees of freedom for the adjusted R squares. Okay, because we are adding some weights. That is what degrees of freedom is. So they differ in a very significant way. If you are more statistical, you can tell this answer, but because you can use, you also divide your residuals by residuals degrees of freedom. So degrees of freedom is nothing but the sample size in that. So the amount of freedom a particular sample has. Okay. So if you are calculating using the sample, you are, if you have a 10 sample, your degrees of freedom becomes 10 minus 1, which is n minus 1, which is 9. So this is purely statistical. That's why I just didn't want to touch the adjusted R square. But there will be some people who want to touch and who want to ask. Then there comes the complication, because when you talk about linear regression algorithm, more statistical concepts also come into the picture. So this is one thing you have to keep in mind as well. So next part is talking about the residuals. So what are residuals and how do you evaluate a linear regression model? So residuals are nothing but the errors which are left over between your actual and your predicted value. So actual minus your predicted value, you are going to get a leftover. That is basically called as a residual. So next is how do you handle categorical variables in a linear regression model? So for example, if you have so if you're doing linear regression means, uh, if you're doing linear regression means actually you are predicting a continuous variable. But in your data set, what if there are some categorical variables also? So how do you handle them? That is what basically the question is. So how to deal with it? If if you don't deal, there is one more bigger problem. So how do you deal with it is one, the method what we do, which is giving the one hot encoding. So that one we already know. Right now, apart from this, we do one more method which is actually regularly done, which is the dummy encoding. So we call it as dummy encoding. Okay, I think we have not covered that when we have done the linear regression part, but there is something called as a dummy encoding. So what is this dummy encoding basically is, this dummy encoding, what does it do is, it is very similar actually to the one hot encoding. But what happens is it omits one category, okay, to avoid multicollinearity. So it creates a dummy variable. What happens is this variable will not allow to get correlation between the independent variables. So it will avoid that correlation between the independent variables. Obviously, it will avoid the multicollinearity problem. This is one thing which is done. Okay, so this is what you can just answer for a simple thing. So I think feature engineering next we have to cover. I think we got a question. Uh, yes, actually we do. We can also use the ordinal encoding also, sir. But the tricky part is I actually didn't want to touch. Good thing you have You have asked. Okay, no problem. There is also something, I was telling you about the one hot encoding, the dummy encoding, and there is one more encoding called as the label encoding. Okay. So usually, if there is an ordered relationship, we do the ordinal encoding part. But the problem is, if assigning the integers to categories. So this is basically label encoding is recommended, or you can say label encoding is done. Yeah, when you don't have any ordinal relationship. I don't think it is available, but I'll tell them to upload. Yeah, I'll share the questions. I'm not sure. I think Aishwarya, I think your name is Lenovo. Okay, so yeah, I'll tell ma'am to upload it in the LMS. Yes, questions I definitely share. I've done a lot of research to find out, what actually people ask in the interviews. So definitely, I'll share these questions 100%. Okay, yeah. So I'll keep this chat aside. Okay. Next is, when we talk about next part, which is the feature engineering part. Okay. So let us talk about the feature engineering. Maybe we can see the questions. Okay. Are not available yet. Okay. I'll check on that. I'll check on that. That they're available. Okay. Uh, Give me a minute. Let me check this. Let me see any questions if I have more. Uh, Using medium. It is median, not medium. Um, Also, we can handle the outliers. Yes, you can handle Aishwarya Vani. Yeah, you can handle actually, but not every time you can use medium. There are some restrictions for using different methods. So based on scenario, you cannot just judge. We say don't cannot judge a book by its cover. So just by looking at the data, we cannot judge that median is a yeah median is obviously a very good measure. Okay, even I have used median to replace empty values many times. So it's a good measure, but not every time you can use the median part. Okay. Uh, okay. So anything else? Anything else? Anything else? Any questions? So if you have any questions, you can ask. Just waiting because till now I was discussing. I didn't ask you guys. You can just let me know if you have any questions. Okay, fine. I think we can go ahead. No, no questions, I guess. Okay, fine. Now, now let me. So this deployment part I'm going to cover in the coming sessions, sir. I don't know, student or faculty, Sanket. I'll cover in the coming because we also have. I'm going to cover the deployment part. Yes. So how do you integrate after building a model? How do you integrate into an application, and how are you going to deploy that? That we are going to discuss in the coming sessions. Yes. So, that's what. So now, this week probably, we'll be doing all the models. I'm focused on, I'll be focusing on the models, very important models like, decision tree, random forest, bagging, boosting, and all those stuff with SVM and all. Then after that, we'll focus on the deployment part. Okay, after covering some important algorithms. So I think that should, yeah, that question, the answer should suffice. Okay. So anything else? Anyone? Fine. Think we can go ahead. Yeah, because we have some more questions also to discuss. Okay, fine. Okay. So let me continue. Next is the feature engineering part. So what is feature scaling and is it necessary for linear regression? So obviously feature scaling is required, when it comes to, any part. But but one thing, when you ask me this question directly, if somebody asks me this question directly, is it required? I will say no, not strictly required or not required. I'll tell you why. One simple answer you can give. Because feature scaling is applied to normalize the data. Correct, no? First of all, to apply linear regression, you need the data to be normal. The data should obviously be following normal distribution. So, if you are saying that the data is following normal distribution, then only you can apply the linear regression. Correct, no? So since you know that the data is normal, why do you want to scale the data? Not required. No, it's already, already the data is following the normal distribution. So my answer is like a yes or a no, yes and a no. So it's like based on situation, but more often than not, you don't require feature scaling, in my opinion, when it comes to the linear regression. Okay. So, usually we do feature scaling. That is why, this question is being asked because, will you do it for linear regression? So you can straightforwardly say it's mostly a no. You don't do it because the data is already normal. So again, I don't want to make it, apply scaling part. So next is how do you handle missing values? So how do you handle missing values in a data set while performing linear regression? So linear regression, we automatically, since we are saying that the data is following normal, we obviously try to apply the Newton's forward and backward interpolation, then use the uh, mean median mode methods, which is particularly we are going to use the median method. Then we are applying some KNN techniques that also we can apply, right? So yeah, we have some methods and we can somehow replace the model. So missing values, sorry. So next is what is polynomial regression? How does it relate to the linear regression? So polynomial regression is nothing but having a nth degree relationship. Okay. So here what we are actually having is we are not having a straightforward linear equation. So we are having a linear equation which is having an nth degree. Okay. Yeah, something which is having an nth degree. For example, like x square, x cube, x power 4, x to the power of 5. If you're having any nth degree, maybe those who are more into statistical, maybe knowing this second degree parabola, power curve. So all these things are nth degree polynomials. Okay. So there is a difference. Something I got. Okay, it is fine. So next is when should you use interaction terms in a linear regression model? So this is again, this question itself, feels what is this question? Okay, it's a kind of a different question. Even I felt it. So what is this interaction term? Is nothing but a yeah, it is nothing so serious. The interaction terms in linear regression model is basically about the you know I can say it is like a combined effect. For example, uh, very I can't say we will not have, but very less. Even I've seen, when you're building a model on linear regression, usually what happens is instead of we just using one independent variable for a particular constant, we use couple of independent variables that is basically called as an interaction effect. That means, for example, when you use it for beta 4, x1 into x2, or maybe you use for beta 5, x2 into x3. So any interaction between two particular independent variables is basically termed as a basically it is termed sorry, basically it is termed as an interaction effect. So next question is, what is the importance of feature selection in linear regression? So what is the importance of feature selection? So very important. Okay. So maybe you can answer very important things like feature selection helps in reducing the multicollinearity that we already know. That's why we are using feature selection, and it also helps to uh, improve the model's performance. Okay, and basically feature selection is basically used also to reduce the overfitting problem. Yes, so to reduce the overfitting problem and mm, overfitting problem you can reduce, and you can focus on the features which are extremely important, and it also helps in reducing the multicollinearity part. Yeah, basically these things you can apply. So for example, methods like the regularization, correlation analysis, all these things you can actually use. Okay. Now let me go to the last part. Some practical applications are there, then we'll go with it. Okay. So next we'll go to the next part, which is the advanced topics on linear regression. So these things, I'm actually leaving it to you. You can just have a try. Okay. But maybe if you're not able to figure it out, you can just, try asking me as well. So these, it's like a homework. So you can just try it. Okay. So even the practical applications, I feel you can just try. Okay. So advanced topics and the practical application. So 21 to 30, you just can give it a try. Okay. So if you want me to discuss again, maybe we can just take some 20-30 minutes and we can discuss. I don't have any problem. We will discuss again. Okay. So a comparison to other models also, maybe I'll leave it to you, okay? Because I just wanted to talk about logistic regression also. So maybe 20, these advanced topics, practical applications, and comparison with other models. Okay, so this actually we can keep it to the other part, because some other time maybe we can discuss, because if few people, I heard a few people are aware of machine learning and they know, for them it is fine. But those who are have not done machine learning, it will be a little difficult. So maybe you can keep it this for a buffer, how to compare with the other models. So especially this advanced topics and this practical applications, you can just have it a try. Okay. So we'll go with the logistic regression part. Okay. So how do you apply this logistic regression and all? We can talk about. Okay. Because I just want to give some brief intro also about logistic regression, because we have already discussed it by a practical aspect also. So I just wanted to discuss on a note where interview perspective and all those things. So let us see how does it differ from linear regression. I think you can answer this question very easily, because logistic regression is more focused on the classification part, right? So I think this one you can automatically address this question, and maybe you can also give the equations, or if you're not if the person is not interested, don't give only. I would never suggest people telling equations in the interviews. Okay, if that particular interviewer is asking you for an equation, very rarely you will actually see people asking. Unless and until he is a very genius and he knows inside out every formula, that at corporate level you do not find people like that. Trust me, guys. So don't just by heart formulas and all. Just when you learn things, fine. If you remember, just tell. Okay, don't break your head too much on by hearting the formulas. Like how you do at school level for writing mathematics test and all. Please do not do that. Okay, so machine learning is a different ball game. Okay. So next thing is explain the sigmoid function and its role in the logistic regression. So sigmoid function, again, you can just give a very simple formula, 1 by 1 plus e power minus z. So that also we have discussed. And basically z is the linear combination, or you can say z is the linear function, which is beta naught plus beta 1x. That's it. And this logistic regression helps to, the sigmoid function helps to predict the, it helps to predict the probability. And the probability obviously will transform by predicting a particular class. So that much you can tell. That is more than enough. So why is logistic regression used for classification task instead of linear regression? This is this is also very easy to because the problem is with the output boundaries or the decision making. Because what happens is, if the data is cannot be put into a straight line, right, or it cannot be built on a straight line. Sorry, it cannot be built on a straight line. The problem is, if you're not able to bring down all the data onto a straight line, how you can use the linear regression for prediction, correct? No, so it is not possible. So keeping that in mind, correct? No, so keeping that in mind, uh, obviously you cannot use the logistic regression. You cannot use the linear regression. So obviously you need a method which can be in the form of a non-linear, right? Some S-shaped curve. So that is in where your logistic actually comes into the picture. So next are, what is the assumptions of the logistic regression? So assumptions, again, the data should be non-linear, correct? No, and multicollinearity should not be there. That is again one more very important aspect, right? And the variables should be independent. Yeah, these are some of the things. So next is explain the difference between the binary, binary multinomial and ordinary logistic regression. So here you can actually talk about the part where right. So here you can talk about the part where what is a binary, which is you're having any maximum of two outputs. Multinomial is something where which has more classes. Ordinal is something where which is in the natural order, right? Like low, medium, high, and like that. Coming to the mathematical understanding, so what is the equation and all? So if somebody asks this question, I told you, mathematical understanding. That's why I have put, because you can't rule out the possibility. of people asking a mathematical formula. So yeah, the probability is very less, but there is probability, and that too we are discussing logistic regression. So so we have to talk about probability, because when we are talking about logistic regression, the logistic regression itself works on the formula, works on the principle of probability. So, so something which is more than the threshold value of probability, then it is going to classify as a class which is above and below. So it works solely on probability. So definitely, we can't rule out that. So definitely, we should talk about the aspect of even the mathematical formulation we can expect. Okay. So what is the mathematical formulation for logistic regression? I think I'm leaving this question to you, because the formulation, how even in my slides I've mentioned where how you calculate and you get the formula for calculating how do you end up with a sigmoid function. So that one I've already discussed. So how does the logistic regression estimate the probabilities? That is the same, which actually talks about the sigmoid function. So it's the same concept on what we have actually already have discussed. So this one, yeah, this particular question I just wanted to talk is the log odds. Yeah, sorry, log odds, which is the, again, this is purely mathematical again, a mathematical question, because I see a couple of people asking this question actually. What are logic or log odds in logistic regression? But more people focus on what is a sigmoid function. How does something come to that function, which is in the form of 1 by 1 plus e power minus z or minus y. So how something comes into that sigmoid function, that kind of question usually you get, but very rarely you will see this log odds function which is being asked. So you can actually tell that log odds is nothing but the occurrence of an output divided by the non-occurrence of that particular output. So I can say in simple language, let us not use that terminology. In a simple language, you can say the probability of happening of an event divided by the probability of not happening. So probability of happening divided by probability of non-happening is what the odds is. So for this formula of the probability of happening divided by the probability of non-happening, if you apply the logarithm part, that becomes the log odds. So log odds, it's a tricky name, log odds, and that log odds usually we call it as odds. Okay, which is probability of happening divided by the probability of non-happening. Okay, fine. So when you apply the logarithm part, it becomes a probability. The logarithm of probability of happening by divided by probability of non-happening. Fine. This name technically is called as a logit function. Okay, we call it as a logit function or log odds. Okay, yeah. So if you want to remember, you can remember. It's up to you. So why is the cost function for the logistic regression not the mean square error? So why? Because we have something called as a because mean square error is basically used for predicting the continuous variable metric. So basically, it is used for regression problem. Instead, what we have for the logistic regression is the something called as a log loss. This is one more term is there. I just wanted to touch this concept in decision tree, but there is one concept which is called as the cross entropy. So cross entropy loss. Yeah, cross entropy loss, which is also called as the log loss. Okay. So there is a function and you have a particular formula for that. If you are very much interested, you can just do some research. It's a very huge formula. Trust me, even I don't remember. Okay, such a huge formula it is. The cost function for the logistic regression. Okay, so I only remember, I only remember, it's called as a log loss or cross entropy loss. Yes, this is what I remember. This is basically used for predicting. I can say predicting the likelihood of occurrence of a probability. Okay, how much chance is there that a particular event occurs? So that is what we use the this log loss function about. Okay. So next is the maximum likelihood estimation in regression. When it comes to the MLE, maximum likelihood estimation is a very important concept. Those who have studied statistics will definitely know this. It's a very important concept in the concept of estimation. So what exactly is this MLE is nothing but how much of probability is there that a particular model or a particular outcome can be predicted. What is the maximum chance that this particular product or so this particular outcome is predicted above the threshold value? So, for example, this MLE is, is, this MLE method, in a very simple language, I will say, this MLE method is basically used to understand that uh, to basically used to understand how much of prediction is actually very much related, very much related or very near to the actual prediction. Okay. So I have a question. Ma'am, I shared. You can just fill on that. Yeah. So let me go to the next question. So implementation and interpretation. So real world applications of logistic regression. You can answer that. And odds ratio we have already have spoken about. How to handle categorical variables. So obviously this particular concept itself is about handling the categorical variables. So so it is very important that you handle the categorical variables using the concept of dummy encoding. Okay, so you can use the concept of dummy encoding and you can actually transform the variables. So yeah, I have to explain this one more thing which is there also. We do dummy encoding actually, but there is one scenario I remember where you cannot do the dummy encoding because what happens is sometimes this dummy encoding also leads to multicollinearity. Again, that is one more issue. Okay. Uh, so you have to be careful in the scenarios where you have to understand which is a right scenario for actually doing the right kind of encoding. So anyway, we have discussed about the impact of multicollinearity on the logistic regression because multicollinearity can be detected by using the correlation matrix. And the most important method is the VIF, various inflation factor. Yes. So various inflation factor and the correlation matrix are the two methods which are used to detect the multicollinearity. Okay. So resolving is basically combining the variables. That is where the we are using the principal components technique, and we also use the regularization part. And if you identify there is more correlation between two variables and those two variables are not contributing to the outcome, you can remove those variables. So even this one you can follow when you have the multicollinearity problem. So next thing is model evaluation. I think, yeah. So we'll discuss this model evaluation and stop. Okay. So model evaluation is something where you have a particular evaluation metrics like the accuracy, right? We have something called as accuracy, precision, recall, F1 score, AUC, ROC curve, and all those things. And that isn't where that isn't where the logistic model actually, or you can say any model which is used for classification problem. Okay. So any model which is used for a classification problem, we can use this metric to analyze, metrics to analyze. Next thing is what's a confusion matrix? So we have discussed the confusion matrix part. What exactly is a confusion matrix? It's a evaluation technique for a classification problem. So what happens in a confusion matrix is it actually predicts the true classes. That's why we have four outcomes. One is the true positive, false negative, false positive and a true negative. Okay. So, very simple language. If you want me to tell what are those four again, anyway, I told you, but still, it's, very simple language. I'll give it very simple. True positive is basically something where the number of positive instances correctly predicted as positive. So this is very easy to understand. Positive instances which is predicted correctly as positive. That is what a true positive case is. Now, the correct condition is true positive and true negative. This is also predicting the negative instances correctly as negative. So this is also correct, no? That is why we call true positive and true negative as correct. Now, the two errors are false negative and false positive. Now, what is false positive? Yeah, we'll take first false positive. So false positive is number of negative instances incorrectly predicted as positive. Negative instances which are incorrectly predicted as positive is what the false positive is. Coming to the false negative part, the number of positive instances incorrectly predicted as negative. That is what the false negative is. Okay. So you can just do some research on confusion. Anyway, I've shared in my PPT and all. You can just have a glance. Next thing is how do you assess the calibration of logistic regression model? So how do you assess the calibration part? So calibration is basically done by training the algorithm. This is basically they are asking the training and testing part. And we use the usually we you know no sorry yeah, so calibration part is nothing but setting a threshold value. Yeah, sorry. So it is basically setting the threshold value which actually shows you how much of assessment you can do based on that particular threshold value what you have actually mentioned. The significance of threshold value, that is the same thing, almost same what we have actually discussed. I got a question. Okay, no. Okay, so significance of threshold is something where you have the most important part of understanding the threshold value is to optimally choose. So usually the default is 0.5 and when you draw the AUC and ROC curve, you'll be able to figure it out that which is the right amount of threshold to give to that particular problem. Or else it will show a direct impact on the cost function. uh, yeah, it will show a direct impact on the cost function. Next is what is the importance of cross validation in logistic regression. So cross validations are nothing but these are basically used to assess the performance of the model. Okay, so there are many methods like the k-fold cross validation. We have methods like yeah, I can say k fold cross validation. Okay. So next question is yeah, this advanced topics I'm leaving it to you. Okay, you can just do some research on this. So comparison on alternatives, that is what basically is about. So that is from my end. So if you have any questions, 100% I'll share, Purva. I'll share these questions. Yes. I have prepared to share it with you guys only. I'll share it 100%. Okay. So any questions if you have, you can ask me. So I think we have covered all the questions, most important ones, particularly on the concept what we have cleared. So covered till now. So I think that part is covered. Now, tomorrow we'll focus on the decision trees. Okay. So if you're able to finish decision trees, we are going to start the random forest as well. And one more important thing is, just wanted to mention, this week we will have a class from 7 to 9 only. 7 to 9, but from next week, most probably, it will be from 7:30. You'll get a confirmation from XLR as well. It will be from next Monday, probably it will be from 7:30 to 9:30. Okay. So it will be starting at 7:30 and ending at 9:30. Okay, 2 hours. So is this for for next week only? So today is day 4, right? So this week anyway we will have another 4 days. So 8 days will be completed. So just for next week and maybe a couple of days after that we'll have. Okay, 7:30 to 9:30. Okay, just please adjust. Please adjust with that. Okay. So anything else apart from that? Any other questions? You can just let me know. I'm done from my end. So you can mark the attendance and the feedback. I think ma'am has shared it in the group. Let me check any questions I got from here. You can use text for eval. You can use the metrics for some text summarizations as well because we are going to discuss the NLP part also. So I'll just touch the important. Okay, so if you want a complete roadmap of which mathematics topics and all, yeah, I'll just mention that in my next session. Okay, so just it will be helpful for the others also. Okay, fine. Just inform ma'am to upload. Yeah. Uh, Sushmita ma'am, you can take over. I think
Yeah, okay, sir. Thank you so
I'll
much.
share the things, ma'am. I already shared. I just please update in the LMS. I think students are asking that.
Yeah, yeah, sure. We will update it.
Sure, sure. Okay, ma'am. Yes,
And
yes, yes. There
yeah,
is,
so
ah,
be off of festival tomorrow. We don't have a session. So we again meeting on Wednesday at 7 p.m. Tomorrow is the leave, so we don't have any sessions. Okay, so students, I see the people are very less. Kindly inform to your friends as well. Ask them not to join by tomorrow because tomorrow we do have a festival, right? So we don't have a session. So leave tomorrow. We'll again meet on Wednesday at 7 p.m. Okay? So, sir, I hope we are done for the day.
yes, yes, ma'am. Yeah, done.
Yeah, we'll wind up for the day. Thank you, sir. Thank you, student. Thank you for joining. Good night, everyone.